Hello, everyone. You are welcome to um, the part four of the series under calculations in chemistry. We are still looking at calculation of relative atomic masses. In the last series, I solved two questions, on the topic. When you are doing calculations in chemistry, you have to solve various questions. There are so many ways examiners can ask or can set questions under every topic. So this is another way they can set question on calculation of relative atomic mass. You can see the last one I solved, the last questions I solved, we were given the relative abundance, of the isotopes, and we are asked to find the relative atomic mass. But today, we want to solve a question where you will be given relative atomic mass and you will be asked to calculate the percentage composition of the relative abundances of the isotopes of the elements. So let's go ahead. This is a question. It's a question from WAEC past question. An element X17 has different atoms containing 18 neutrons and 20 neutrons. If the relative atomic mass of X is 35.5, find the relative abundance. So we are looking for their percentage composition. So what we are going to do to solve this question, the element, the isotopes, the first one is 17, X17. Okay. Second one, don't forget isotopes have the same atomic number. So the number here is what? The mass number. And remember, I gave you a formula that mass number is equal to proton number plus neutron number. So to get the mass number of this one, I'm going to give me 17 plus 18. So the first mass number will be 17 plus 18, and that is 35. The second mass number will be 17 plus 20. Okay, 17 plus 20, and that will be 37. Okay, so I hope this is clear. So we have X1735, X1737. So the next thing now is, since we are looking for percentage composition, and you know that the total percent of any quantity is 100. So you can say let the percentage composition of this one, let's be A. Then for this one, it's going to give us 100 minus A. Okay, this is percentage composition of the isotopes. So this one is A, this one is 100 minus A. Now, to get the relative atomic mass, it's going to give us, this one will be A, the percentage of this one in the, don't forget we use the what? We use the molar mass. And we are calculating relative atomic mass. So the relative atomic mass is going to be A percent of 35 plus 100 minus A percent of 37. That means A percent means A over 100 times 35 over 1 plus 100 minus A okay, 100 minus A over 100 times 37 over 1. The addition will give us the relative atomic mass, which is 35.5. So the rest of the work is just mathematics, just to go and find A. Just to find the value of A by simplifying this. What is A times 35? We have 35A over 100 plus 100 minus A over 100, okay, times 37 is equal to 35.5. You know, when you find the LCM and cross multiply, you're going to have 35A plus 37 into 100 minus A is equal to 35.5 times 100. Okay? If we open the brackets, I'm going to have when we open the brackets from here, I'm going to have 35A plus 3,700 minus 37A is equal to, this will give us 3,550. 3,550. Okay. The next thing is to collect like terms. This will give us 3,700 minus 3,550 is equal to 37A minus 35A. Okay, I brought this to the left, took this one, took the A to the right. So 37A minus 35A, that will give me 2A. So 2A is equal to, if you minus 3,550 from 3,700, we're going to have 150. So therefore A is equal to 150 divided by 2, which is 75. Then the second one will be 100 minus A. 100 minus A will be 100 minus 75, that's 25. So the answers are 75% and 25%. So 75% is the relative abundance of the first isotope that has 18 neutrons, and 25% is the relative abundance of the second isotope that has 20 neutrons. So these are all the questions, you know, examiners can ask you under calculation of relative atomic mass. So this is the end of relative atomic mass. So the next series, we're going to start looking at how to write electron shells. So please, if you find this teaching interesting, don't enjoy it alone. Please share the link with students in secondary school, those who want to write WAEC, NECO, IGCSE, and even UTME examination next year. Okay? Share it with them, let them enjoy the series. Thank you and God bless you. See you next class.